This video looks at algebra and adding and subtracting terms. The first thing to be very much aware of in algebra is that we can only simplify like terms when we're using addition and subtraction. So the first thing that we need to do is understand what like terms are. Like terms are terms that have the exact same variables at the end of them. And before we go to do any adding and subtracting, we're going to have a look at identifying some like terms. So here I have a jumble of terms and I want to just pick out which ones are like terms. Okay, so I'm going to just give you a moment. I want you to pause the video and I want you to see if you can pick out which terms are like terms, which ones end in the exact same variables. Okay, so plus 3x plus 2x and plus 5x are examples of like terms. They all end in x. Plus 2b and minus 3b are like terms. They both end in b. Plus 3y and minus 2y are like terms. They both end in y. And if I look at 4a plus 4a and minus 5c, they don't have any match in this group. So I don't have any like terms for 4a and I don't have any like terms for minus 5c. Okay, let's do that one more time. Okay, so again, I've got a jumble of terms. Pause the video here again and see, can you pick out the like terms in this group? Okay, I'm going to start with plus 3ab. So I look through the group and I pick out anything else that ends in the exact same variables. So I don't see any ABs, but I do see something. Do you know what it is? It's this 4BA. Now we tend to write our variables in alphabetical order, but sometimes somebody will write them in a different order. However, as long as you still have the same variables, you still have a like term. So AB, BA, they can go together. What else can I match up? Okay, so I've got minus 2AC, and I can match that up to plus 3AC. And I can match up plus 4a and minus 2a. And I can also match up plus 3xy with plus 2yx. And this is again another example where the variables are in a different order at the end, but I still have the exact same variables. So I've got x and y, I've got x and y, they're both there, so I've got like terms. I've also got some constants, plus 7 and minus 1, they count as like terms. They don't have any variable at the end, so they end in the same thing if you think of it that way. And finally, I'm left with minus 2x and minus 2x squared. Now, these do look an awful lot alike, so it's really tempting to say that they're like terms. They both have a minus 2, but we've already decided actually that the coefficient doesn't actually make a difference in terms of identifying like terms, because we can see, for example, that plus 4a and minus 2a were like terms. They had different coefficients. So the coefficient isn't your deciding factor. It's the variable at the end. So the minus 2 doesn't really mean that I should match these up. I look at the variables x and x squared. Now, x squared is different from x. So since it's different, it's not the exact same as x, then these are not like terms. Okay, so now let's look at using like terms to add and subtract. Okay, so here's our first example. First of all, note the instruction. The instruction for the question is to simplify. Simplifying in algebra basically means doing anything that can be done in the question, whether it's adding or subtracting or multiplying or dividing. In these examples, we're going to be looking at just adding and subtracting. Okay, so the first thing that I need to do before I can add and subtract is I need to identify my like terms, because I can only add and subtract like terms. So 3x plus 2x are like terms, and plus 4 plus 1 are like terms. So now I can put the like terms together. Okay, so what do I get? Well, first of all, dealing with the x terms, I've got 3x plus 2x. So I'll put those together and I'll get 5x. Notice that when I add my like terms, that all I really do is add the coefficients. So 3 plus 2 makes 5. The variable stays as x. The variable doesn't change when I add and subtract. Next, I've got my plus 4 plus 1. When I work that out, plus 4 plus 1 is plus 5. So when I simplify this expression, I get 5x plus 5. There's nothing else that I can do in this particular question, because what I'm left with here now, these two terms, 5x plus 5, these aren't like terms. They don't end in the same variables, so I cannot reduce it any further. I can't add these together, for example. I will just write it as the expression 5x plus 5. And this is my solution in this case. Okay, so here's a second example. Again, it asks me to simplify, just tidy up. 4a minus 2b plus 3 plus 4b minus 2a plus 1. So I want to take this expression and I want to add and subtract what I can. And of course, I can only add and subtract like terms, so the first thing that I must do is identify these. In your copy, write down this expression and highlight the like terms. Pause the video while you do this, and then when you've that done, play and see if you were correct. So 4a and minus 2a are like terms. They both end in a. Minus 2b and plus 4b are like terms. They both end in b. And plus 3 and plus 1 are also like terms. They don't have any variable at the end. Can you remember the name that I give to a term that has no variable and just a number? It's called a constant. So plus 3 and plus 1 are constants in this case. So now I want to do my bit of tidying up. I can put my like terms together. Again, pause the video at this stage and see if you can do this yourself. Okay, so this time I've got 4a minus 2a. Okay, so I'm going to look at the coefficients. 4 minus 2. 4 minus 2 is 2. So I'm going to say 2a for those two terms. Then I've got minus 2b plus 4b. Again, it's the coefficients that will do the work. So minus 2 plus 4 is going to give me plus 2. Don't forget to put the variable at the end. It's plus 2b. And finally then, plus 3 plus 1 is going to give me plus 4. And this is my simplified expression. Don't forget to put your signs in between your terms. Okay, let's look at the third example. So this time I'm asked to simplify 2x plus 3y minus x plus 5y plus 2xy. Again, write this in your copy and then pause the video while you identify the like terms. Okay, so in this case, my like terms are 2x and minus x. I've got plus 3y, which matches up with plus 5y. They both end in y. And this term at the end, 2xy, that doesn't have any like terms. No other terms end in xy. So now that we've identified our like terms, pause the video again and then see if you can do the correct simplification to get to the final line of this question. Okay, so before I begin, I'm just going to note that for my like terms, 2x and minus x, it looks like I've no coefficient on the minus x. But actually, we spoke about this in an earlier video, I can put a value in front of x. Again, think about it like, how many x's can I see? I can see one x here in this bubble. So I can put a 1 in as the coefficient here. The coefficient, excuse me, keeps track of how many there are of a particular letter. So now I can put these together. So 2x minus 1x is going to give me 1x. Onto the y's, plus 3y plus 5y. Again, the coefficients do the work. It's going to be plus 8y. And what about the 2xy at the end? Well, it doesn't have anything to partner up with, but it's still part of the expression, so I'll just write it at the end. And this is how my simplified expression looks. Okay, here's example 4. So again, write example 4 into your copy, pause the video, identify the like terms, and then play and see if you're correct. Okay, so looking at this, I can see that I've got an ax term at the start. So I'm looking now for any other terms that end in ax. So I've got plus 2ax, and I've got plus 3ax. So they're all like terms. And I've also got plus ay matching up with plus 5ay. And this minus 2 at the end doesn't have a partner. There's no like term to go with that. Can you remember again the name for a number by itself in algebra? This is called a constant. What do I call the letters again? They're called the variables. And what do I call the numbers in front of the variables? These are called the coefficients. Okay, back to our simplify. I never wrote that instruction in this time. I'm just going to write it in now. Okay, so I want to do my bit of adding and subtracting with my like terms. Again, pause the video here and see if you can complete this yourself. Okay, so looking at my terms circled in pink, first of all, I've got a potential issue because this ax doesn't appear to have a coefficient, and the coefficients do the work for the adding and subtracting. But there is actually a coefficient I can write in for this term. Do you know what it is? So again, if there's no coefficient in place, I can put in a 1. So 1ax plus 2ax plus 3ax. I'm just adding up the coefficients 1 plus 2 plus 3. So I get 6ax for that term. And notice I've got the same issue with the ay's. So I've got plus ay plus 5ay. If there's no coefficient, I can stick in a 1. So I've got plus 1ay plus 5ay is plus 6ay. And then even though the minus 2 doesn't have any like terms, it's still part of the expression, so I won't ditch it. I'll just stick it at the end. So minus 2, and I'm finished simplifying this expression. Okay, so let's finish this video with a problem-solving question. Okay, so I've sketched a shape, and it looks like it's probably a rectangle, and I'm actually going to tell you that it is definitely a rectangle. Before we get into the algebra of it, just sketch this for a moment in your copy and have a think about what notation, what symbols I should mark in to my diagram to make it really, really clear to somebody who was looking at it that it definitely was a rectangle. Pause the video for a second while you do that. So let's think, what are the features of rectangles? Well, I know the opposite sides are equal in length. How could I show that? So I could put 1 dash through each of these and 2 dashes through each of these. Okay, so I'm getting there, but I'm not quite ready to say that it's definitely a rectangle yet. What else should I mark in if I wanted to be very clear about it? Well, I know that a rectangle has right angles in the corners, so I should mark in right angles. At this stage, I have enough to be absolutely certain it's a rectangle, but you could fill a little bit more in if you liked, which is to indicate that the opposite sides are parallel. How could you show this? So I've just marked in some arrows on these 2 lines here and these 2 lines here to indicate that they're parallel. So now I've all bases covered. This is definitely a rectangle. And now we'll go back to the algebra. So I'm going to tell you for a fact that this top side of my rectangle is 4a plus 2 units long. And I'm going to tell you that this side of my rectangle is 2a plus 3 units long. Now, I'd like you to take a moment and look at this rectangle and see, on the basis of this information, is there any more that you could fill in? We've already stated that opposite sides of the rectangle are equal in length. So if this side is getting called 4a plus 2, well, this side must be the same. What about this side of the rectangle? Well, it's going to have to match this side over here, isn't it? So I can call it 2a plus 3 as well. Okay, so now for the question. So our question is, write an expression for the perimeter of this rectangle and simplify if possible. Pause the video here while you try to complete this question and then play and see if you're correct. And if you get stuck at any stage, maybe play a little bit and see if it gives you enough of a hint to proceed. So first of all, the question's asking about perimeter, and the way that I get a perimeter of a rectangle is by adding up all the sides. So I'm going to start my expression by doing that. So I've added 4a plus 2 from the top, plus 2a plus 3, plus 4a plus 2, plus 2a plus 3. Bring me right back to the start. So we've written an expression now for the perimeter of the rectangle. So we can tick that part of it off our list. And now we want to simplify if possible. Okay, so simplifying means do any jobs that I can do in the question. So everything is adding in this particular example. So if I want to be able to do that, I need to go looking first of all for my like terms. So let's have a look through this expression for the like terms. So all of these a terms are like terms, and all of these number terms are like terms. And again, just think for a second about my vocabulary. What do I call numbers by themselves? So they're called constants. What do I call the number in front of a letter? It's called a coefficient. What do I call the letters themselves? They're the variables. What do I call each individual bit? They're the terms. What do I call the whole thing together? an expression. Okay, let's do our tidying up. So 4a plus 2a plus 4a plus 2a. Again, it's the coefficients that I'm really working with. So 4 plus 2 plus 4 plus 2 is going to give me 12. So the a's tidy up to give me 12a. And then my constants, plus 2 plus 3 plus 2 plus 3, they tidy up to give me plus 10. And this is our simplified expression. And this is as much as we can do with the information available to us. We can't say for definite what the perimeter of the rectangle is because we don't know what a is worth. So for different values of a, we'd have different perimeter values. That's why algebra can be so useful. It can allow us to adjust values on the basis of variables, like in this case our a.